Dear learners, welcome back to Motors and Controllers, which is a new model in Unit 4 of Hybrid Electric Vehicle. Once again, I am Dr. R. Venkatachalam, Professor, KSR College of Engineering. I welcome you once again for this wonderful session. So, today's content for presentation is motors, types of motors, characteristics of DC motors, AC motors, permanent magnet motor, switched reluctance motor, then torque vectoring, then regenerative braking system, inverter, rectifier and DC-DC converter, then conclusion. So we will start with types of motors, or what is motor. It is an electric machine that converts electrical energy into mechanical energy. So most electric motors operate through the interaction between the motor's magnetic field and electric current in a wire winding to generate force in the form of torque applied on the motor shaft, which is very well used to drive the all kind of rotating sources. An electric generator is mechanically identical to an electric motor but operates with a reversed flow of power, converting mechanical energy into electrical energy. So motor also can function as a generator sometimes. So that is why we are using it as a motor cum alternator. Motor will deliver the power to the wheel, then alternator will receive the power from the wheel and produce electricity that will be stored in the battery, which is called regenerative braking system. If you talk about motor, the basic principle of operation is very well known that a north pole south pole magnet is there. There will be a flux line between them. If a conductor cuts the magnetic field, there will be a EMF induced, that is electromotive force will be introduced. So that can be captured and stored in the battery, then the battery will have the power. So electric motor can be powered to direct current source such as from batteries, rectifiers by alternating current, AC sources such as power grid, inverters and electrical generator. So that is how it will function. So the battery, if you think opposite, the battery is powers, the positive negative power is there, that is fed to the electromagnetic field. So north pole south pole, due to the repulsion, the coil will start rotate. So it will again, the shaft fitted in the rotor will be connect to the power. So now we will see the different types of motors, that is electric motors. It can be majorly classified as DC motors, that is direct current motor, then alternative current motors and other type of motors. In the DC motor classification, DC shunt motor, separately excited motor, series motor, PMDC motor, then compound motor. In AC motors, induction motor, synchronous motor. Other type of motors can be classified as stepper motor, brushless motor, hysteresis motor, reluctance motor, universal motor, like that we can classify. We will see one by one in the later slides. So characteristic of a DC motor we will see now. So characters of a DC motor can be expressed in three ways. A curve can be plotted with torque and armature current, speed versus armature current, then speed versus torque. So in the figure you can find three curves. First one is torque versus armature. So initially it linearly, that is torque directly proportional to the armature current. So the torque will be produced like this. Then speed and armature current. Whenever speed required, the current also increases. When the speed become higher or with the low load, then less current is used. If you compare the speed versus torque, it is a replica of the speed versus armature current curve. So AC motor, alternate current motor, now we are seeing the single phase AC induction motor, which is a brushless motor designed with a single stator coil. So if you see the figure, the starting winding is there, then main winding is there, that is L1, L2, then the switch is there to on off, a capacitor is there, and a squirrel cage rotor is here. So the voltage is applied on this parallel to this. So by supplying the electricity, it will rotate. Then we will move to three-phase motors or the AC motor, that is a specific example of polyphase, single phase or polyphase we can say. The motors can be either an induction motor or it also called as synchronous motor or asynchronous motor. This motor consists of three main components: stator, the rotor and the enclosure. So that is casing. Here we can have the three phase RYB, that is red, yellow, blue, it is the classification, and also it has star connected rotor, then rotor frame and a slip rings are there. There is a shaft which connects the rings as well as the rotor winding. Brush is there, then external stator connected to rheostats also there. So comparison between single phase and three phase AC induction motor. The single phase motor has two terminals and it requires only two wires to power it up, and the three phase motor has three terminals and requires the 3 or 4 including neutral wires to operate. The power factor of a single phase induction motor is low when compared to the three phase induction motor. Whenever the more power supply is required or more power to be driven, three phase is preferable. You can see the images plotted here. The first one is single phase power supply, then three phase power supply, which starts with different angles that you can see. The line between the angle between the phases is 120. If you divide 360 into 3, then it will be 120. Permanent magnet motor, that is shortly we can call it as PM motor. It is also a type of electric motor that uses permanent magnets in addition to the windings in the field rather than windings only. So fundamental operation of a permanent magnet motor is like most electric motors. The outer stator holds winding of coils fed by a power source and the rotor freely rotates based on the forces imparted by the stator coils. So the circuit connection you can see in this figure. Switched reluctance motor or SRM motor, or simply you can say SRM. So this is the connection we have here. The working principle of the switched reluctance motor is it works on the variable reluctance. That means the rotor of this motor constantly tries to align through the lowest reluctance lane. Formation of the rotary magnetic field can be done using the circuit of power electronic switching. So benefits of this SRM is it include high motor drive efficiency and reliability, low overall system cost and increased performance. So the circuits and all you can witness in the figure. So one of the important factor in EV or HEV, the torque vectoring is very much important. It is a computer controlled system that controls how much power your car engine or motor sends to each individual wheel. That is more important. That gives the driver the confidence level to drive the vehicle. So controlling power more effectively, a car with torque vectoring will have more grip on slippery surfaces and can accelerate more quickly. So torque vectoring technology is a vehicle's ability to vary its torque for its each wheel. So it can enable a car to transfer torque between a given wheel or axle based on cornering. If you take left cornering, so left side wheel will rotate less distance. The outer or right side wheel will have more rotation while taking left curve. So this concept will accordingly functions to distribute the torque even to the wheel with different speeds. So this is how torque vectoring is working. So it normally works by piggybacking on the natural properties of a differential, which allow one wheel on an axle to go faster or slower than another wheel. So Mitsubishi defined the technology with its active yaw control on the Lancer Evolution 4 rear axle vehicle. So regenerative braking is an important system which is used in all electric vehicle as well as car. You can find all electric car will have regenerative braking system, and hybrid vehicle also will have regenerative braking system, which regenerates energy during braking that will be stored through the battery. Whenever it required, it will retrieve to give the power to the motor. On a normal car, braking simply wastes energy, but with regenerative braking, some of the energy is able to be reused. So it can enhance the performance and the efficiency of the vehicle. Regenerative braking harnesses the energy expanded while slowing a vehicle to help recharge the battery, tapping into the ability of an electric motor to turn into a generator. This braking system still depends on uncontrollable variables, because a driver may experience unexpected situations to brake suddenly or slowly or very rapidly or quickly. So it depends on different variable uncontrollable parameters. The regenerative braking system has a variety of benefits, like the driving range can be extended for an electric vehicle, and the efficiency of braking can be improved, decrease the brake wear. So that is also possible. So rectifier is the important component in as well as a hybrid electric vehicle and electric vehicle. It is a converter of electric current, that is alternating current, AC to DC. So that is how it can work. The reverse operation is performed by the inverter. So in inverter, DC will be converted to AC. This including alternating current. Electricity provides power for a AC load, for example an electric vehicle's EV electric traction motor. So rectifier is a similar device to an inverter, except that is does not opposite converting AC power to DC power. So inverter, so it is opposite to the rectifier. So it can convert the DC into AC. Whereas AC is the power supplied to industry and homes by the main power grid or public utility, the batteries of alternating power system store only DC power. So inverter is a device that converts DC power to the AC used to electric vehicle motor. So EV is also what's called a VFD, variable frequency drive, so which required inverter. Sine wave AC power can be generated in a wide range of different frequencies. So DC-DC converter, which is used to unstable or improper voltage supplies, can lead to characteristic degradation of even malfunction. To prevent this, a DC-DC converter is need to convert and stabilize the voltage. So this is a device which stabilizes the voltage using a DC-DC converter is referred to as a voltage regulator. So DC-DC converter can also named as voltage regulator. So the first step is to select a converter IC. So decide DC-DC topology will narrow the choice. If the input voltage is greater than the output voltage, choose a buck type topology. So in order to conclude the drive system which is available for electric and hybrid vehicles, the performance of hybrid electric vehicles largely depends on the effective integration of electric motors, power electronic controllers, high efficiency motors such as PM synchronous motor, that is permanent magnet synchronous motor, and induction motors combined with sophisticated control algorithms enable precise torque control, regenerative braking, and seamless power sharing between multiple energy sources is possible. So the further research is required in motor design, power electronics, and intelligent control system is expected to drive the next generation of high performance hybrid electric vehicles. So with this we will conclude this session. We will meet again. Thanks for your time for watching this. Thank you.